thank Ministry of Consumer Affairs for especially signing up the MOU with IIT BHU to pursue and leverage the areas of digital meteorology, especially in India. So, with that perspective, in fact, I was just preparing certain slides. So, actually, in legal meteorology, when even I was searching a variety of literature, certain books, and other things, now even across the globe, there are many more things which are taking place. But certainly, legal meteorology requires more awareness, your secretary Rohit ji was emphasizing in recent YouTube video you shared, that artificial intelligence, next generation technologies, blockchain, certifications, and eventually Jago Grahak Jago is the most important part. जहां हमें कंज्यूमर को वहां तक पुल करना है, और ना सिर्फ पुल करना है, हमें उसे वो टूल्स भी देने हैं जहां वो उसको वाकई आसानी से अपनी एक कंप्लेंट लॉन्च करे और इमीडिएटली बैकएंड की पूरी टीम हमारी उसको सपोर्ट करे और उसको जस्टिस दिला सके. So with that view, nowadays actually the technology is growing so very well that it is now really possible to connect to millions and millions of customers, provide them good services. If they have some grievance, we can always immediately redress them. And not only that, using artificial intelligence platforms, sometimes even maybe a one-to-one human might not even assist. It may simply be an automated machine which will redress him for his grievance. So now machines are becoming so very intelligent. So artificial intelligence, recently the application of Chat GPT, it is coming up with such a very powerful, as a very powerful tool and a solution where most of the available knowledge can be instantly generated. So sometimes wherever consumer has some basic understanding or requirement to understand something better, automation can also help them well. And then certainly at certain level, human intervention would be required. The way we see in most of the helplines, after some steps, it always asks, do you want to connect to our human assistant? So this is how things are really progressing. So anyways, being a teacher especially, hamara to whenever we start talking, we talk about matlab, we become bookish and prefer to go deeper into the technology. So in today's talk, I would actually be trying to bring out what is actually there in the next generation technologies that may help us for legal metrology, leveraging legal metrology, and what are the focus areas, especially in terms of blockchain secured, because traceability is a very important aspect in legal metrology, and the certification should be renewed, authentic, cannot be falsified or muted. So there are a number of things, and with the advent of artificial intelligence, cyber physical systems, Internet of Things, now it is really possible where we can gather all the data in real time. Since millions and billions of devices are there, instruments are there, we would be eventually gathering huge amounts of data. And then all that huge amount of data, since it will carry information, because any machine can fail at any time, right? So real time data will immediately help us finally analyze it through artificial intelligence tools and identify the bottleneck. And if some equipment or facility is going wrong, immediately we can intervene there, revise their certification. It may not so happen that a wrong product can keep on being used, and consumers in effect would be sufferers, right? So with that view, let us start our discussions. Let me take up the matter. Okay. So I believe I have certain slides, so I can share my screen. Right now, can't share the content. So the host. So just see what is to be done. If some setting needs to be changed. Yeah, now I can do that. Thank you. Okay, so is my screen visible? Right. Okay. So hello, everyone. I'm Dr. Rajput from IIT BHU Varanasi, and I'm associate professor here in Department of Electronics Engineering. I have given my sometimes using tools is very handy. So I have given my WhatsApp number as well as my email ID. So please feel free to contact me at any point of time whenever you deem necessary. So today we will be talking about emerging technologies and approaches for next generation legal metrology. So basically, legal metrology is a field. I'm just reiterating from my perspective, the way I envision it, right? So most of the things might already be known to you, but what I actually want to emphasize before you all is my thoughts with which we would proceed further. So, legal metrology is a field that deals with the application of measurement science, talks about regulations, creates standards to ensure fair trade, consumer protection, and public health and safety. Right? It plays a very critical role in ensuring the accuracy and reliability of measurement. So, this thing is very important, accuracy and reliability of measurement in various industries, including manufacturing, health, light, food, and not only manufacturing, healthcare, and food production, rather in every the sector of societal life, right? So this is and then the legal metrology is the branch of metrology that deals with regulation and enforcement of measurements and measuring instruments in the trade. So it plays a critical role in ensuring fair transactions. So one thing is very important, which is fair and accurate transactions. We have to promote consumer protection, maintain market integrity, and with the advent of digitalization, now legal metrology is undergoing through a transformation which is changing the way our measurements are made, recorded. So we do measurements, we record, and then this legal metrology is enforced. So the regulations are properly enforced. So if we consider the digitalization in legal metrology, right, it will increase accuracy and precision of measurements, right? And therefore digital measuring instruments, what maybe these examples. So electronic weighing scales, as we are seeing, even grocery stores, or even the vegetable sellers and the other people, eventually they have migrated to, mostly migrated to electronic weighing scales, right? So generally tampering of digital systems is not very easy. So this is slightly secured, but there are many other ways by which it can be tweaked, right? Then we have digital thermometers, we have flow meters. They all offer superior performance compared to analog counterparts, right? So they can measure precisely, reliably, and consistent results are achieved. Even I always feel like that when I buy some item from a grocery shop, even it measures like 1000.10 grams. Earlier it used to happen in a way that when someone used to weigh, he even used to add plus 50 grams and kind of. But nowadays, sometimes it is so accurate that if you have to get 1,000 grams, then you will literally get only 1,000 grams plus point 1 gram or 10 gram. So you see the precision, resolution, and the perfection. So in one way, consumer is certainly getting 1 kg, but the seller is also really able to make the most out of the products, their products they are selling, right? They are reliable, provide consistent results, and reduce the risk of errors and accuracies. And therefore, uh, digital measuring instruments are the future, and almost everywhere we should push it. It does not mean that only the display is digital. Measurement systems, the transducers, even at the level of transducers, we have to make them digital, right? So there are many other ways by which we can do that, right? So digitalization enables, now since you have digital information, you can automate measuring processes, you can reduce the need of manual intervention, increase efficiency, and the speed with which we are measuring, right? So electronic registers and databases allow for the automatic recording and analysis of measurement data, right, which helps to identify trends and anomalies quickly. For example, even I would say like your Google Pay. So when we use, or we talk about Paytm, right? You might have observed that where I spent even 12 rupees or 20 rupees or 100 rupees, 1000 rupees, right? So earlier we were able to remember what transactions have we made. Now with the digitalization and electronic register and database, eventually what is Paytm and GPay? They are all electronic registers and databases. They keep on generating databases even after 10 years, 5 years. Even I really appreciate when I check my transactions in Google Pay. I can even check the payments which I might have made in 2018, kind of, right? So this really gives you a very good capability to identify trends and anomalies. And now you understand, even this is how even credit cards also give you how well you are spending, so they can analyze. So with digitalization, things would be very accurate, and the analytics would be possible. So we can detect early and resolve potential issues such as fraud or inaccurate measurements. So digitalization facilitates creation of robust and interconnected ecosystem for the legal metrology. I'm just reiterating the things which generally we understand well, but we will soon reach over the content that would be in depth. Okay, so we are able to integrate different stakeholders, manufacturers, suppliers, regulators, and enhance their collaborations. Okay. So, in conclusion, digitalization is transforming legal metrology by enhancing the accuracy and precision. So, my specific message to the community is that consider complete digitalization of metrology. And once we analyze this, you will find that there is a significant part where still digitalization is remaining, right? So if we do the transformation, it would improve consumer protection, improve fair trade, and ensure market integrity. In fact, yesterday I was listening to the sir's comments regarding the market integrity and the way they even maintain and analyze the pricing even of grains, dals, rice, and other things. which is being consumed by millions of Indians, right? And not only the way the crops are being produced, sometimes the weather is not very supportive, and certain crops fail, and there is a possibility of a price rise. So if we can predict certain things well in advance, certainly we can intervene, right? So digital metrology refers use of digital technologies, right? And this is an era that has been enabled by rapid advancement in digital technology, particularly in the fields of computing, sensors, and data processing. So if we talk about digitalizations or digital era, so in digital metrology, three components are important. One is computing, one is sensors, and the data that we are processing, right? So earlier, metrology was largely manual and time consuming. Okay. The physical measurement had multiple issues, even interpretation of the unskilled people, and it required significant expertise. With the advent of digital technologies, it has become much more efficient, accurate, and reliable, right? So it involves wide variety of range sensors, right from lasers, cameras, optical instruments, even precise measurement of the physical objects is now possible with digital metrology, right? So even we can even by using sensors, uh, we can process this digital data using advanced algorithms and software tools. Okay. We can even accurately find the measurement of the measurement. We can measure the size, shape, surface finish, and other properties, which normally different humans would interpret in different manners, right? So all such platforms can be used for a wide range of applications, quality control, inspection, and sometimes even we can do reverse engineering, right? So there are multiple advantages of digital metrology. We can capture large amount of data securely, accurately, and save it for future. It enables manufacturers to improve the quality of their products, reduce weight, and improve their manufacturing processes. Even when Rohit sir was discussing, he also told us that sometimes even we analyze the data of complaints and identify such companies which are receiving more complaints, or certain specific products are actually receiving significant complaints, right? So even it is the mandate under legal metrology to inform to such manufacturers about their products. So until we digitalize things, how would we know? So the digital metrology is has to come in a very big way. It is already we are at the threshold where things are happening very well. So overall, the era of digital metrology represents a significant step forward in the field of measurement and quality control. Okay. So as the technology advances, new and emerging technologies are being developed to improve legal metrology practices. So today we will discuss some of the emerging technologies and approaches for the next generation of legal metrology. And this is actually today's context. What exactly is the future and next generation technologies which we have to talk about? And within that, the very first and most promising, most enforcing, and most decentralized platform or technology is blockchain. So, blockchain is a decentralized, secure, and transparent system that can be used to create tamper-proof records of measurements and transactions. So, in fact, in financial sector, in financial sectors, you might have talked about digital currency, Bitcoin, etc. Right? Blockchain's first highly impactful area was the cryptocurrencies, and from there they came up that even they don't require reserve bank or a control of a centralized bank, or there is nothing where the money will be stored. But blockchain is a technology which can be used at many different platforms, and today I will talk about how do we implement blockchain for legal metrological aspects. Okay, so this technology can be used to create an immutable record. Immutable is very important, you cannot hide. So we can create immutable records of measurements and transactions, which can increase the transparency and accountability in legal metrology. So it has the potential to improve the field of legal metrology, deals with accuracy of measurement and weighing systems. So there are few potential applications of blockchain for legal metrology. Okay, so we will talk about what are potential applications, and then we would specifically consider one example application of blockchain in this area right today. So very first thing is ensuring accuracy and traceability of measurements. So you have to increase accuracy and traceability. If something, if some instrument is measuring instrument, even if I talk about electricity meter, or if I talk about fuel pump, fuel stations, and other places, right? So blockchain can be used to record measurements and weighing data in a tamper-proof and transparent manner. This can help ensure the accuracy of measurements and provide a verifiable audit trail for any dispute that may arise. Okay, so the very first thing is ensuring accuracy and traceability of measurements. The second thing is verification of calibration and testing. So how well you have calibrated certain instrument, and what technologies have been used to test it, right? So we can use blockchain for this verification. So blockchain can be used to record the results of calibration and testing procedures for measurement and weighing instruments. Okay, so this will ensure that instruments are properly calibrated and tested to meet the required standards. Okay. Then another application is certifying measurement and weighing instruments. So I can certify. So blockchain can be used to create digital certificates of conformity for measurement and weighing instruments, right? This can help ensure that the instruments have been properly tested and verified before they are used in trade and commerce. Okay, so verification and certification of instruments is another very important thing which we can carry out through blockchain. As I told, this blockchain information enclosed or added in the blockchain are immutable. So once information has been added, you cannot delete or remove by any means. Even the government cannot do that, right? So that is a very important thing to ensure the liability, responsibility even of the government, implementation agencies, and of course the consumer and the manufacturer, right? Then another thing is tracking and monitoring supply chains. So we can also use blockchain for supply chain, right? So this can be used to track the movement of goods and materials through the supply chain. This can help ensure that the products are accurately weighed, measured at each stage of the process, and from the manufacturer to the consumer when it reaches, he can always track. Even if I talk about some vaccine, And suppose during the transportation process there was some part during which the vaccine, which was supposed to be falling under 3 degrees centigrade temperature, which might have always been stored, by mistake, some in some intermediate path, there may be some lacuna, because of which the temperature of the vaccine might have gone up to 4 degrees or 10 degrees centigrade, and maybe for half an hour or 1 hour or 3 hours it had been exposed to higher temperature. But later on, when I bought it from the medicine shop pharmacist, it may so happen that I will get it in a cooled, well placed, well packed environment. Okay, so how would I know? So if I use blockchain, and at each individual level, intermediate level, if I can continuously track and store the blocks of information, so at each storage level, at each movement level, I can keep on having this temperature based data. Maybe I am only capturing the temperature of the vaccine by using some IoT enabled device which keeps a track of the temperature of the vaccine while it is being shipped. And whenever the temperature rises, I can continuously see the graph over which over the whole process of transportation, right? So this is how tracking and monitoring of supply chains is very important, not only from the angle of the pricing and quantities and the way they were maintained. In fact, I can add value add for the information. Okay, so here we can see this is an example of a blockchain application for tracking the supply chain of electric vehicle batteries, right? This is a research paper I have given the DOI as well, document identifier, and the link where it has been discussed. So here we are talking about the battery, the blockchain of battery system. So here you can see that when I started on day one, I started the blockchain, digital flow, blockchain network, right? So what was the artificial graphite, manganese, nickel, cobalt, lithium, polyphins, aluminium, copper, all the material that was used was of what quality, what certification level, what purity, from where it was bought, and many other things. So, all such information will be placed in this block one. So, if I say that there are so many blocks of this chain, right? So, you will find that this blockchain, so the very first block will contain all the accurate information, detailed information of from the manufacturer and from where he bought this copper, right? Or aluminium, what was the quality level of this. And this will be automated process, so you don't have to do it manually. And this information is placed as first block. And then what was the next process of mixing? This is placed in the second block. Then at the third level, how it was coated, the third block. Then how it was compressed, fourth block. Then how was it dried? Then how was it, for what period it had been sitting, right, at the manufacturer end. And then how, after the resting period, how anodes, cathodes, electrolyte separator, and its packaging was done is stored in next block. And then battery management system, details of this, then another block. In this way, right from bottom to top, now finally is the user. So user will buy a product, this battery, along with the whole blockchain, right? So if user has to check whether my material used was wrong, or the drying process was wrong, or battery management system has failed, he can always go to the redressal agency, for example, the Ministry of Consumer Affairs, some other department, or redressal place of redressal, right? It is not really necessary that the user should be given rights to see all the manufacturing process, but in the case of any grievance or any dispute, investigation agencies can always check the whole block. So depending upon, so we will maintain the privacy as well. User will be allowed to check for the blockchain, the last block, the certificate of the available in the blockchain. If required, he may be allowed to go to the previous state, and like this, if permissible, he himself, the user can himself be allowed. Otherwise, respective agencies can go back and finally find that, oh, there was a difficulty in the battery pack assembly, right? So this is the advantage of blockchain, that we are empowering the user to trace back. And the most important part is that this chain of block is dedicated to specific battery one, battery number, say 110394758 This is the serial number of the battery, and each battery will have a blockchain, right? So this is how each battery is absolutely secured, how it was packaged, how it was manufactured, where was it placed, for what many years, how it is being disposed, even at the final end when it reaches to the cycling company, right? How they have recycled and how much amount has once again been recycled down to creating or taking out, extracting all the elements and metals using which it was created. I can go back and trace. Now, since the whole thing will be digital, it will empower the government, the mining industry, the manufacturer, the OEMs, the users. Everyone will have complete command and control on the information on each individual product, right? So that is the beauty of creating, and this all became possible because we are doing digitalization of the industry. Okay, so meteorology should be digitalized, implemented using most advanced automated technology. So various computers will keep on creating blocks, adding blocks in the chain, and this information is non-trivial, will always persist. No one can mute it. That will be very helpful, right? So I believe this is how you can understand and realize how very important blockchain is, right? Then another very interesting application is smart contracts for trade transactions. In fact, I always feel overwhelmed when I think about my interaction with Ashutosh ji, the office senior officials in Ministry of Consumer Affairs. The DOCA is so powerful, so knowledgeable, that it was really surprising for me to see that the ministry operates at such a very high level. So I would certainly look forward to give you the example that when Rohit sir was in Rajasthan, they implemented some blockchain enabled smart contracts for paintings. They embedded the details of the painter and the price at which this painting was being sold uh, uh, by the painter to the immediate buyer. Okay, or the industry, in the seller, right? So he bought it for certain amount, and then uh, cost plus percentage share of profit, right? on the sale of painting, right? So now what happened? At stage 1, the painter sold the painting which had certain cost, maybe very very low cost, maybe 100 rupees only, right? And then he added a contract that whenever this painting will be sold further by the seller who bought it only for rupees 100 in the commercial market, whatever profit he would make, the painter would be given a royalty or a share of the sale by 10%. So what happened? The first sale was 100 rupees. The next sale, this intermediate seller sold it to Delhi, maybe for 1000 rupees. So once again, its 10% was paid back to the painter. Then from Delhi, this painting was exported to Dubai. At Dubai, it was sold maybe for an equivalent amount of 1 lakhs. So once again, since it was a blockchain based smart contract, once again another 10% of 1 lakh was paid to the painter, because now it was sold to another buyer, right, at 1 lakh rupees, and that buyer finally sold it in UK museum for maybe 1 CR rupee, INR rupees 1 CR, right? So once again, it's 10%. Since it was in a smart contract, the painter got the information, and once again, he received this 10% of the profit, right? So I mean, and since this was immutable, this painting was containing a blockchain logo, a blockchain based information. So whenever it was sold, another block of information was added, and accordingly needful information exchange was even sent to the painter. So now what would happen? Now painter for, and this has been done for each and every painting uh, they had considered, right? So what happened? Now wherever this painting is and wherever it is being sold, every time the original owner, the maker or painter of the will always be informed, right? Just consider and think, if the painting of Mona Lisa was under a smart contract, and its returns were under a blockchain, then wherever and whichever museum is hosting it will always keep on paying the family. Okay, so that is a very important and interesting thing. So overall, the blockchain technology has the potential to improve the accuracy, transparency in legal so these so this example falls within the prerogative of legal metrology, that even we have to ensure that the trade transactions that are taking place would be very good. Okay, so blockchain was the very first technology which we talked just now. The second technology which is very important is Internet of Things. Internet of Things is what? Internet of Things means there are two machines which are talking to each other, and there is no need of human intervention. For example, your washing machine is internet enabled. So if washing machine is sensing some fault in its circuitry or in some component or something else, whatever changes are taking place, accordingly it will create a log and transmit it to the manufacturing company. Okay, the service center. Now service center will receive this information sent by washing machine, not by the owner of the washing machine. Now this information goes to this service center. Service center checks for the information, its service contract, and based on that sends a repairer person who comes, mends the machine, and once again reverts back with the information. So sometimes it may so happen that even the owner has not been informed that there was a fault in the washing machine, and the company person came and repaired and went back. And if it was under warranty, even charges were not required. Similar is the case of insurance agency when a car meets an accident. So the IoT enabled sensors would immediately generate that information, and that information will be immediately sent to multiple places. Number one, it will be sent to police department, an FIR is to be registered. It would be sent to the health department or a hospital, from where an ambulance can come along with necessary assistance. Similarly, immediately the insurance company will also be informed that there is a difficulty, right? So immediately the insurance agency will send a drone with camera and audio system, and when maybe right after the accident, within 10 minutes, the drone camera can come to the place of accident, create do the needful videography and take pictures of the accident, so that claims could be settled. And based on that information, immediately the company was informed, the service agency of the vehicle, right? So they will immediately come, and immediately the rescue team will also come to take the vehicle back to the service station and repair. Now, because of the Internet of Things, FIR was made, hospital was informed, service center was informed, insurance agency was informed, and all of the, and even the drone was also a machine. So drone took images, it took it back to the insurance agency, where artificial intelligence analyzed this accident, the extent of accident and the claims that would come up. And based on that, automatic approval for the repair of the vehicle was also done. Whatever hospital charges were there, that was also covered by the insurance agency. Since FIR was also made, the police agency and the insurance team, they interacted together through machines, and even took the FIR that okay, this has been reported, and accordingly all the matters are settled, right? So in case of Internet of Things, there are significant there is significant scope of its application in legal metrology, right? IoT devices can be used to collect real-time data on measurement and transmit it to central database, right? So which can be accepted by the regulators and the stakeholders, right? So IoT devices can play very important role even in case of legal metrology, measuring instruments, and how an instrument is working. So even I would look forward to use Internet of Thing based control system, monitoring system, even implemented at each fuel station. So from every petrol pump, fuel pump, from wherever you are getting, we have to receive consistent information of the good health of the fuel dispensing machine, right? And since it comes to the central database, if there is a difficulty at the manufacturer level or at the stakeholder or the vendor, right, all of these are informed and needful action can be done, right? So this will provide a network of connected devices that can be used to monitor and control the measuring instruments, right? So IoT can help legal metrology in several ways, including number one, improved accuracy. As I placed IoT devices even at the fuel station or the fuel pump, right? uh, Keep on monitoring the health of the fuel dispenser, whether it is measuring accurately or not, right? So number one, accurate measures are made. It will automatically correct for the temperature and pressure changes. even other environmental factors that can affect the accuracy of the measuring instrument. So at different seasons, different temperature ranges across India, over one full year, even I can keep on providing or adding automated compensations for temperature, pressure, humid change in humidity, and environmental factors. And IoT devices can do all that automatically, backed up with artificial intelligence based platforms, and we can keep on improving the accuracy of the system or unit under target, right? Then IoT can also do remote monitoring. What I was suggesting, in case of fuel pump, this information is being sent to a central unit, right? So central unit, a central database. So what is happening? We are measuring and observing the fuel station remotely, right? Possible. It has been possible by IoT. So IoT can do help us even do the remote monitoring. So the third technology is very important, and which is remote monitoring. So IoT devices can allow for remote monitoring for measuring instruments, enabling regulatory authorities to detect and respond to any issue in real time. Then data analytics. So now you see, since we installed IoT device at the fuel pump, it was generating real-time data. Even the vendor was not informed, even the regulator was not disturbed or harassed. However, this huge data which is being gathered from respective fuel station, its information is being stored at the data center. Now, using AI platforms, artificial intelligence, this data analytics is done. And accordingly, regulators can identify the patterns and trends in the use of measuring instrument, right? In fact, as we might have studied, there is a bathtub curve in case of fault tolerant devices and products being manufactured. So there will be some period. So this is the time, and this is the failure rate, right? So initially on day one, there will be infant mortality rate. This is the period when failures of a device would be many. Then there is a significant time, maybe 5 years, 10 years, kind of 5, 10, 15 years, during which the machine will work very well. And usually this infant mortality period is hardly about 1 year, right? And then there is a period of end of life. There is a period of end of life and wear and tear starts, right? So this is the period. So if we have IoT devices and the way characteristics of certain instrument is changing, we can identify the pattern and do predictive maintenance also. So we will also see that, right? So automation. So what is automation? IoT devices can automate many tasks. For example, the compensation and other things. So it can, the tasks involved in legal metrology, including you have to recalibrate some fuel pump, you have to verify the measuring instrument, right? Reduce the workload on the regulator and increase the efficiency. So IoT devices can help at many areas in legal metrology. So IoT is another upcoming technology. So it would be good if even every single measurement unit can have a SIM card and set of sensors on IoT platform, so it can sense the real-time pattern and transmit it to the central server where it can be continuously monitored. What I mean to say is that using IoT platform, you can keep on observing each and every single unit. And that is why the IPv6, right now we are in IPv4. IPv4 is identification number, you can understand it like this: identification number for every single compute unit. Every single device will have some IP address, right? Now with IPv6, which is now coming, although it has yet not come in vogue, every single machine, product, device, item will have its own independent identity, right? Across the globe if it is on the network, right? So what will happen? Every single unit is identifiable. Every single bottle you are selling, everything which is on the internet, connected on the internet, and who will connect if any, even bottle of water uh, through the internet, IoT devices, right? So if you can enable your product on IoT, right, it can keep on uh, checking. In fact, one very good example I would like to say is MG Hector, a very nice vehicle which claims that it has internet inside, right? So what it does, even when I drive this vehicle and come home after a trip, every day on the app, it gives me marks that today's my drive was 95% satisfactory. Even when I rash drive that vehicle, sometimes my evaluation comes down to 65%, and it says that, and on the Google map it shows me where I applied intense brake, harsh brake, or where I took a sudden turn, or sometimes different anomalies in your driving are identified and informed, and based on that they evaluate your driving to be of certain level. Even in fact, when I drive very well, I get even 100%, right? Now you would ask, why are they gathering this much data? Because number one, they enabled this vehicle with internet of thing devices, so there is a SIM card identified communication protocol, and this particular individual vehicle is transmitting its real time data on the cloud, on the company's cloud. So they know the health of my vehicle. Sometimes I get information, a message that, dear sir, please send your vehicle for service. There are certain aspects which need be corrected. Okay, so as a consumer, or a driver, I don't know it, but they are sensing the pattern. So this is called predictive maintenance. Predictive maintenance, right? So for predictive maintenance, so they do that. And now the question is, why are they gathering this much data, and why are they evaluating my drive every time? The truth is, they have promised that if I want to sell this vehicle after 3 years, they will buy back the vehicle at 70% of the price, right? So if I bought it for 20 lakhs, I can get sell it for just a price below 70%, right? So I will still get 70%. Now, the question is, if I have been driving my vehicle very well, they can settle this sale immediately and can give me 70% of the day one price immediately. So I can sell back my vehicle back to the company. But however, if I find, if the company would find that by you have been driving your vehicle very badly, and in fact, sometimes even your drive quality came down to only 20%, that means you are not keeping the vehicle in a good condition, and therefore the settlement made can only go up to 40% of the committed price, because you have not been a good driver and you have not maintained the vehicle well, right? So in one way, what is happening, it is they are doing the meteorology, they are verifying, they are maintaining the vehicle, and they can always show me the data why they are not able to give you complete settlement or committed package, right? So, however, the use of IoT in legal metrology also raises some concern, the way the example I talked just now, right? So, such as the potential for hacking and cyber attack. Now, you suppose you just assume if my vehicle got hacked and erratic data has been uploaded on the company's cloud, they will. So even if I am a good driver and if I am driving it efficiently up to 100%, right, company might receive a data that my product, my vehicle is only worth 20% of the compensation, right, because it was hacked and wrong cyber data has been uploaded. Similarly, I have been driving well and suppose I myself hacked this communication protocol, and even if I drive my vehicle badly and if I upload 100% high performance on the cloud, once again, this will create a difficulty, right? So, we have to ensure that such systems are not hackable, need to ensure the security and privacy of the data collected, right? Now you see, since this internet inside enabled vehicle is capturing all my driving on the map, even suppose if I am moving to some new place, the company will always know where I am going, right? Maybe I'm a common man, so it doesn't matter a lot for me, but suppose I was a billionaire and I had to ensure and I had many enemies, and therefore the privacy of the data collected is has to be ensured, right? So it adds to certain responsibilities as well. So the concerns must be addressed in order to ensure that the use of IoT in legal metrology is implemented safely and effectively. And then now the next technology which is of very high importance is artificial intelligence. In fact, all the previous examples which I have, technologies which I have been talking about, you see, I was talking about that this huge digital data can be analyzed. Who will analyze it? Artificial intelligence. And would a human be able to cross check? Of course, a human can cross check some random results, but can it cross check every output which this AI model will give? Not possible, right? So, somewhere use of artificial intelligence may be good, because you using machine learning and natural language processing and other things, we can analyze large amounts of data and identify patterns that may be missed by humans. So AI is very useful. So in legal metrology, AI can be used to identify anomalies in measurement data and flag them for further investigation. So if a fuel station is running faulty, such anomaly can be identified. The vendor can be informed even during the period for which for the period during which the equipment fuel dispenser is under fault. It may be compensated. Suppose it is now delivering only 90% of the quantity, so accordingly we can compensate it for plus 10% more, so that user eventually gets at least 1 liter what he deserves or what he pays for, right? So identification of anomalies in measurement data, and then further investigation can be done, right? So, some examples on how AI is being used in legal metrology. So what are we doing for under this legal metrology? Verification of weighing and measuring instruments. So all the instruments who are measuring, right, the digital data is being captured. So AI can be used to verify and calibrating weighing and measuring instruments. For example, AI algorithms can be used to analyze images of weights and measures to detect any defect or irregularities, right? So even the weights and measurements, the very basic thing, right? AI algorithm, so using some computer vision, you can capture the needful data, and whatever data has been captured, based on that, you can detect any defect or irregularity in the weights and measures, right? So this is one way. Then data analysis and processing. Now AI can be used to process huge amounts of data. From where are we getting this huge amount of data? From various instruments which we have enabled through IoT platform, right? So this IoT platform is providing you large amounts of data in the data center, and then AI models implemented at the data center are analyzing it continuously, right? And generating flags for needful verification and correction, right? So this can help to identify patterns and trends and to detect any errors or discrepancies in the data. And if data is erratic, of course, the instrument, respective instrument might be at fault, might be running faulty, right? Then another application of AI technology is quality control and testing. All of you are laboratory persons and you are observing that quality control and testing is done at each laboratory level, right? So have you automated this, or is are we still pursuing the manual activity? If it's not so, then we have to think about AI implementation. What kind of right data is to be generated? And if that good data has been generated, that digital data has been generated well, then we have to check whether which model will analyze it, and how can I automate my quality control and testing process. So product inspection and material testing. So this can help to ensure that product meets the regulatory standards and specifications. So this is the next aspect of this. Then as we said, my vehicle captures data through internet on IoT, right? Through IoT platform. And whenever my vehicle generates some internal pattern which is not matching with the goal pattern, right? That is, there are some discrepancies in the system engine performance or vehicle performance, vibration is more, some particular component is generating additional or consuming more electricity, or it is having more additional friction, right? The vehicle can monitor and capture such digital trend, and AI is used to predict when weighing and measuring instrument may need maintenance or repair, right? So various weighing and measurement instruments, even a fuel dispenser. So as I said, in the bathtub curve, when the wear tear would start, right, what component has to be replaced, or if the performance is degrading, how to repair, how to maintain, right? So actually, in one way, by digital metrology, what you are doing, you are generating fault tolerant digital system, right? So this is what we are doing. So this can help to minimize the downtime and prevent equipment failure. So suppose the fuel dispenser goes faulty and it has to be replaced, and some component will come from other city, it may take some time. So during that period, your equipment will be at will be fully down, right? So if I can predict in advance, and if I can sense that some component is going to fail in some time because of certain digital trends, digital information, so I can beforehand do the predictive maintenance. And in fact, this is just like annual service or AMC. So the person concerned from the service center comes to us every 6 months and says, sir, your equipment has to be serviced. What are you doing? In one way you are doing the predictive maintenance, but however, are you checking for the faults? No, he just came to service. But in IoT enabled, AI processed systems, digital systems, we can check for fault tolerance and its health pattern. And when almost 70% of the performance, if some performance degrades or gets down up to 5% or 10% or 20%, as the threshold you might set, right? Accordingly, before it actually goes down, I can immediately I beforehand I can do a predictive maintenance. And this is what my internet connected vehicle, they keep on sending me messages that there is some predictive maintenance required, so please send your vehicle for to the service center. And this is how, whenever I have to go even to some remote place like 10,000 kilometers or 5,000 kilometers drive, I even never go to the service station, right? So predictive maintenance of vehicles, instruments, devices can be done using artificial intelligence. Then another very important technology is non-destructive testing. In case of non-destructive testing, what happens? You are not going to touch the equipment, you are not going to damage the item or equipment, but by measuring the properties of the materials, you can assess it. So this technology can be used in legal metrology to measure the properties of products such as density, moisture content, even without damaging them. You are not going to open that, right? So non-destructive testing is very important. So this is a method in which various industries, including legal metrology, to evaluate the quality and integrity of materials and products without causing any damage, right? So in legal metrology, NDT is used to ensure that measuring instrument used for trade complies with the relevant standards and regulations and provide accurate measurements, right? So this is a very important aspect, non-destructive testing. So my question is, in our laboratories, are we doing it? If yes, this is a matter of proud. If not, then we have to check whether how much percentage is being covered through non-destructive testing and other things. Although I am not a man of legal metrology, not working with your laboratory specifically, so sometimes I may sound slightly more theoretical, but certainly this collaboration with IIT BHU, we would actually learn to and learn from you by working in your laboratories, and would look forward to actually learn and update ourselves from the world of books and theoretical practices into real time world. So by theory we would look forward to implement more components of non-destructive testing, right? And would even look forward to implement IoT enabled systems, blockchain enabled systems in your laboratories, how you are generating certificates, that we can also do. So there is significant scope of joint activities. So NDT techniques used in legal metrology, they use ultrasound testing, radiographic testing, eddy current testing, magnetic particle testing, liquid penetrant testing, and many things. Different techniques have their own advantages and limitations, right? And the choice of technique depends on a specific application and the material being tested, right? So the very first thing is ultrasonic testing. So this is commonly used to detect internal defects and measure the thickness of materials, such as pipes, tanks used for liquid storage. Radiographic testing. Radiographic testing is used to detect flaws and irregularities in material that cannot be seen with the naked eye, maybe internal cracks, etc. So, such as in welds, weldings, castings. So, such radiographic testings can be done, right? Then, eddy current testing is what? It detects cracks and other defects on the surface of conductive material, right? While magnetic particle testing is used to detect surface and near surface defects in ferromagnetic materials, right? So, how eddy currents are being generated in in certain medium, right? Even if there are fractures, if there is some air encapsulated inside or things, so it would start heating. So eddy current has different types of effects, right? And if calibrated well, eddy current testing the technology is very effective. Then liquid penetrant testing is used to detect surface defects in non-magnetic materials. So there are different ways. So in general, in legal metrology, NDT is used to ensure that measuring instruments such as scales, meters, and gauges are calibrated and accurate to the required standards. This helps to protect consumers and ensure the trade is fair and transparent, which is the actual prime motive of the legal metrology, right? So this is used to verify the quality and safety of the product in various industries, including aerospace, automotive, and construction. So, in general, non-destructive testing plays a crucial role in legal metrology and is an important tool for ensuring the accuracy and quality of measuring instrument used for trade. Okay. Then another very important thing is remote sensing. Remote sensing is what? Generally, we understand remote sensing by satellite-based sensing, use of lidars, light detection and ranging, right? So, of course, remote sensing is that thing, but it is just not limited to the satellites and radars. Even it could be remotely operated sensing, right? As we were talking about IoT enabled. So I can sense something, I can monitor something, even I can capture the real-time physical parameters remotely of different measuring instruments as well. So in legal metrology, remote sensing can be used to measure the size and shape of land parcels, which is important for property valuation and taxation. You might have seen or utilized the application, Google Map application, right? So we have digitalized mapping system, and now I can very precisely identify how much is my area. And if I talk about specific coordinates, then using GIS and remote sensing, even the remote sensing should also be clubbed with geographical information system, GIS, which is even precision to 2 millimeter lengths, right? So its resolution is very high. Whereas in remote sensing, if it is done through satellites or airborne instruments, this accuracy maybe in centimeters or sometimes even in meters, right? So satellite-based remote sensing has low resolution. GIS-based instrumentation system sensing will be very high. Okay, so resolution will be very good. So, what are different examples of remote sensing technologies in the legal metrology? So, the important thing is 3D scanning. So, 3D scanning can be used to measure the dimensions of products such as bottles or containers. Okay, to ensure the compliance with legal requirements. So, we can do 3D scanning. So, it can provide accurate measurement even for irregularly shaped objects. So 3D scanner is one very important thing. Laser based distance measuring. So laser based distance measuring devices can be used to measure the distance between 2 points, such as the height of a building or length of a rod. So so you using even remote sensing, we can do such things. They will provide accurate and fast measurements. We can do thermal imaging as well. So thermal imaging cameras can be used to measure the temperature of products such as food to ensure compliance with legal requirement. So this technology can provide non-contact measurement. So thermal imaging is non-contact type, which is particularly useful for measuring the temperature of hot and hazardous substances. So this is also another very important thing. Then weighing scales. Remote weighing scales can be used to measure the weight of products such as fruits and vegetables to ensure compliance with the legal requirements. So these scales can be connected to a computer system which can automatically record and analyze the data. For example, the loaded and unloaded trucks. So measuring how much item has been loaded on a truck. So usually it is done through computer based remote weighing systems, right? So such weighing scales have been placed like this. Then another very interesting the imaging measurement system is X-ray imaging. So X-ray imaging can be used to measure the density of the products such as metals to ensure compliance with legal requirements. So this technology can provide non-destructive testing and can be used to detect defects or impurities in the product. So generally, our laboratories may be equipped with such non-destructive technology-based tools and platforms. And if platforms are available, we can always start utilizing, come up with many other innovative ideas. So we don't have to always follow the Western world or developed countries, how they are doing things, but there is significant scope of our own innovation and implementation of innovative approaches which we can do, right? So in conclusion, remote sensing technologies can provide accurate and efficient measurements and inspections, okay, which can help ensure compliance with the legal requirements in trade and commerce. So, so these were the basic five technologies which I wanted to emphasize for use in the coming period. Okay, uh, what are these? One is your blockchain, another is your IoT, another is your AI-enabled systems, then non-destructive testing and remote sensing, right? So these are the basic, the immediate five technologies which we may emphasize for further use, right? So in conclusion, emerging technologies and approaches such as blockchain, IoT, AI, NDT, remote sensing, and some more. If we have more time, we can discuss about many more technologies, right? So they offer new and exciting possibilities for the next generation of legal metrology. By embracing these technologies, legal metrology can become more accurate, efficient, and transparent, ultimately benefiting consumers, businesses, and society as a whole. Right? So, this was the primary five technology based exposure for the next generation of legal metrology. Now, although we have limited time, but I would look forward to pick up one clear example of blockchain. So let's talk about some potential applications of blockchain for legal metrology. Okay, so आशुतोष जी,
Yes,
आशुतोष
sir.
जी,
Yes, sir.
आप मुझे मुझे बस 1 मिनट दीजिएगा, मैं तुरंत वापस आता हूँ, ठीक है?
Please take your 5 minutes. I think we can take 5 minutes break. Please.
नहीं नहीं, ब्रेक की जरूरत नहीं, बस विद इन अ मिनट आई विल कम बैक.
Please, sir. Please.
Yes. So now I am back. So we can,
Please, sir.
yes.
Please.
So now we will continue further. I believe the talk is being slightly bookish, but I actually wanted to emphasize things and push our
It's not
community.
bookish, sir. It's not bookish. It is actually practical. What is actually required? It's a complete, blockchain. What is required in the legal methodology? It is a
Yes,
blockchain of legal methodology.
but truly speaking, through you I am learning so many more, and I am really happy that from the world of books we will be actually touching the consumers benefits, that the working on various high-end technologies eventually to benefit the society. And in fact, this is the purpose of the whole setup. All the departments, ministries, government,
True,
eventually
true, sir.
the end beneficiary must be our societal benefits. So all technologies, all engineering, all institutes, all the manpower and efforts eventually should lead to the advantages which we should get. So okay,
Thank,
let's continue.
thank you. Please, sir.
So
Please.
is my screen visible now?
Yes, it is very well visible. Please, sir.
Right, right, let's go ahead. So now after this much discussion and motivation, let us typically talk about one specific application of blockchain. So a few potential applications of blockchain in legal metrology. So a blockchain technology has the potential to improve the field of legal metrology, which deals with the accuracy of measurements and weighing systems, okay, used in trade and commerce. So few potential applications of blockchain for legal metrology. So what are these? So the very first thing which today we will discuss at length is ensuring accuracy and traceability of measurements. Okay. So blockchain can be used to record measurements and weighing data in a tamper-proof and transparent manner. So this can help ensure the accuracy of measurements and provide a verifiable audit trail for any dispute that may rise. This is what I was referring to in when we were talking about the blockchain for a battery system. Right from how metal is, what kind of metal is used, how it has been processed. So I mean, at each and every level, there is a certification, there is a verification, and there is a repository of information. So we should understand that blockchain is a repository of information right from day one to day of recycle. For example, if I talk about a human chain, and if all humans have a blockchain sticker placed on their heads, right from day one, what you ate, how you slept, how much exercise did you do, right from your birth, if I can maintain a blockchain for each individual at any point of time, even for example when his selection is being done for some national service, or maybe for matrimonial purposes also, since this blockchain information is immutable, I can always cross check the information, how many times you have been ill, what kind of exercises have you been doing. I mean, it's a kind of a repository of complete information. So even if at certain point in my life, if I become depressed, I can even know what kind of situations, circumstances I had been going through, which has led me to depression. Right? Sometimes cardiac difficulties are there. Sometimes psychological issues arise. Sometimes medical situations come up. Right? If you have a blockchain and if you can monitor and analyze your patterns, we can always detect. So this is the advantage, that you can ensure the accuracy and traceability even of the measurements. Okay. So today, in this particular example, I will be referring to a research paper which is very interesting and simple research paper, which is block technology to visualize the meteorological traceability. So this has been published by the first author Toshiyuki Takatsuchi from National Meteorology Institute of Japan. I loved this research paper. Although it is a very simplistic paper, and there will be lot more information to be covered. But I strongly recommend that people should study through this research paper. Most of the content in subsequent slides have been taken from this research paper, right? So you can even cross check. Sometimes I might have modified it in my language, sometimes I might have used it in verbatim, right? But this is the primary reference. So with in the light of this publication, let us have the subsequent discussions, right? So meteorological traceability is defined as an unbroken chain of calibrations to a national or international meteorological standard, and only the reference standard which is located immediately upstream in the calibration chain is shown on a calibration certificate. So when you would issue a calibration certificate, right, uh, this will be referred to a reference standard available locally. However, this reference standard is also referred to international or intermediate standards as well, right? So blockchain technology makes it possible for the owner of the certificate to visualize the chain of calibrations to the primary standards. Okay, so a owner can go back up to the whole chain of calibrations up to the primary standard. So we are not talking about merely the secondary standards. Okay, it also provides the prevention measures of falsification of the certificates, assurance of authenticity and integrity of the certificates, and access control of the certificates. Right. So now you can see it has covered almost everything. It provides the prevention measures of falsification of certificates, assures authenticity, ensures integrity of the certificate, and who can see this certificate is also controlled, right? So in some companies all measuring instruments are calibrated by external calibration laboratories. So such companies actually do not calibrate their equipment and things this, but they get it calibrated by external calibration laboratories. Okay. While in other companies, only high level measuring instruments are calibrated externally and other low level instruments are calibrated internally. Okay. So in any case, the chain of the calibration must be linked to external calibration, right? That is, in any case, the chain of calibration must be linked to external calibration laboratories, and eventually the chain reaches to the national or international primary standards so that the meteorological traceability is established. So right from primary standard up to the user end certificate, right? Everything should be transparently available for me to verify where the error might have entered. So in recent years, the blockchain, which is the core technology of Bitcoin, has been used not only in financial technology but in many other fields to register information on the internet. So in this talk, we will be discussing an example registering system as published by these authors of calibration certificates equipped with a new function, right? So traceability is a general term which means the ability to discover information about where and how a product was made. Traceability has been required for quality control of industrial products. For example, even under ISO 9000, quality control is necessary, right? So with the growing increase of the public concern for food safety, traceability has also become common in food industry, and blockchain is recently often used to record documents in food traceability systems. So traceability, as we explain in this talk, is meteorological traceability, which also has a good affinity for the blockchain. So meteorological traceability is the example which we are talking about. So the calibration certificates in which the results of calibrations are recorded, right? So calibration certificate kya hoga? This will be the one which will store the results of calibration in a recorded form. So they are shared by both the laboratories which have performed the calibrations and the client, who will be called as the owner of the certificate by means of a paper. Now, by using the blockchain technology, the calibration certificates can be registered on the internet. So rather than physical paper based exchanges, now we can register the certificates on the internet. The user, the owner, the laboratory, or any third party company who wants to verify, they can see the blockchain, provided we allow them. And for this allowance, the certificates can be encrypted, and therefore only these two parties can decrypt them, so only they can see. If necessary, the certificate can be disclosed to a third party by giving decryption password. So हमने privacy भी protect कर ली, encrypt भी कर लिया, और we have ensured that it is authentic, unmuted, non-falsified, and integrated, right? So integrity of the certificate is also maintained. So even such a simple use of blockchain is an effective tool, and we can come up with more sophisticated systems. So अभी primarily हम लोग देख लेते हैं. So meteorological traceability is defined as the property of a measurement result whereby the result can be related to a reference through a documented unbroken chain of calibrations, each contributing to the measurement uncertainty, right? So this is how we define it. Okay. So the reference described here is deemed a national or international standard called primary standard. तो होना क्या चाहिए? सारा का सारा सर्टिफिकेशन सिस्टम हमें पता होना चाहिए. So the whole view of the traceability chain should be like this. I should be able to check every single certificate even up to the primary standard, right? Nevertheless, on a calibration certificate, which an owner can obtain, only a reference measuring instrument which is linked immediately upstream in the traceability chain is shown. तो अभी क्या होता है? The reality of a user is only this. This is what I issue to him. He is the end user or the manufacturer or the owner, right? But if he wants to cross check whether how what was this and this, no one knows. This one also not disclosed. Only the laboratory will know. So that is the gray area where we do work. So the traceability chain which the owner can see is truncated as shown, and there is no way of knowing if chain is properly linked to the primary standard or not. Although since this certificate has been issued by accredited labs, right, or government agency, it is expected that it is very well linked with the primary standard, because we are also members of the international consortium and societies, right? So at all levels, we stay well connected. However, if I have this anxiety to know what is the backend, right, I should be able to correct it, right? So there are cases where the source of the traceability is not a material standard which is traceable to the SI units. For example, some chemical measurements are performed in accordance with the standard procedure. In any case, the path of the traceability is linked to a national metrology lab or similar. Okay. So, if the calibration certificate is issued by an accredited laboratory, the traceability is assured by a relevant accreditation body, right? In particular, the logo mark of the International Laboratory Accreditation Cooperation ILAC Mutual Recognition Arrangement MRA is stamped. So ILAC MRA is stamped on the calibration certificate represents higher credibility. So in most cases, there is a strong need for the owners to know the traceability chain of the certificate which they obtained, right? However, if the owners want to know the traceability chain as is shown here, so a user can go back to this and can go back to this. So this is how a certificate was generated step by step and the user gets it, right? So the way to access is scarcely provided. So it is not given. So some reasons why the owner needs to know the information: to which country the certificate is linked in the traceability chain is the information which the owner wants to know. कौन से standards follow हो रहे हैं? And we believe the owner has a right to know it. So even if the traceability is assured and linked to certain national standard, not all national standards in the world are approved internationally. So national standard may be something, but it may not be fully linked with the international platforms. So the country which the certificate is linked to is often unknown even by the calibration laboratory or the accreditation body. In case of in case there is a skepticism in the certificate and the proficiency test for confirmation purpose is planned, the country which another certificate used for the comparison is linked to is important information. If both the certificates are linked to the same country, existence of a systematic bias cannot be denied. So transparent linkage is need of the day, right? So when the traceability chain is considerably long, it may happen that the first calibration of the primary standard was performed considerably long time ago. Primary standard, right? Some owners are willing to know the traceability chain, including a timeline. Okay, because now user is more aware. A owner or manufacturer may want to know this. After the revision of SI units, which is on the cards, whether previous or new definition has been used for the calibration is an interesting manner. So things may be obsolete. And therefore, a new and simple design of blockchain to overcome these concerns is being discussed here. It enables owners to verify the traceability chain of their measuring instrument and to use them without any anxiety, right? To overcome the concern, the blockchain, a kind of information technology, is used. So, blockchain was invented as a means to register transactions of virtual cryptocurrencies on the internet, right? Cryptocurrencies are transacted only by data processing on the internet without real currencies or centralized banks. So, cryptocurrencies are virtual currencies, but no one controls it. So now the application field of the blockchain is no more limited to financial technology only, whereas the first breakthrough was on the blockchain was in the financial technology, right? Cryptocurrencies came up in a very big way. The blockchain enables to record any sort of information on the internet. So this is the crux of our discussion, that blockchain enables to record any sort of information on the internet, right? So here is a simple explanation of the blockchain can be given for the readers who are not familiar with the information technology. So हम लोग उसको एक simple way में समझ लेते हैं. So huge numbers of transactions of cryptocurrencies happen concurrently all across the globe. Each transaction record includes the information of a payer or a payee, right? The time and date of the transaction. Now, many transactions are collected into one data set at regular time intervals. This is called a block. Now, blocks are uploaded on the internet in chronological orders, and the series of the blocks is called blockchain. So, who paid to whom at what date and time has been recorded. Now, this record will be floated on the internet and once verified is included in the chain of the payments. Okay, so this is how blockchain will monitor and keep trace of every single transaction which has been made. So blockchain is a huge data set which includes all transactions in the past. Blockchain is copied and stored in many places on the internet to prepare for any data loss or system down and to prevent falsification. So since infinite copies of the blockchain are available, every block is unique, cannot go off, cannot be removed. You can wipe up certain computers, but not everywhere, right? So eventually, blockchain, and since this is a network of networks, blockchain technology, it's impossible, it's very much impossible that anyone can actually hack it, although there are some algorithms and publications where people say that how people can influence it. But in general, if it is a public blockchain and if it is a very large blockchain, it is not possible to do so. Although in case of metrology we will see a different approach, right? So the simple blockchain explained above can easily be falsified. Hence, the concrete blockchain is carefully designed so as not to be falsified, right? So, and therefore, for this purpose, a hash function such as SHA-256, developed by National Institute of Standards and Technology USA, is used. Okay, so in blockchain, hash function SHA-256 is minimally used. Now, the hash function is a very interesting thing. Hash function is an irreversible calculation protocol which will have certain hash value, and this hash value can be calculated from the source data, but from the end data cannot be created back. I mean, if I have used it in forward direction, its reverse is not possible. So I can never know what was the original information. For example, you might have observed that when we change password in emails, you are allowed to overwrite, submit a new password, but they do not show the old password. Although they say that it is not matching, but they verify. How? This password will never go back. So even Google also doesn't know what is your actual password, because right after submitting your password, it converts into some new hash function, and finally that hash function is saved. Whenever you will feed your password, it will be converted into equivalent hash and that hash will be matched, right? What was that unique hash? Google will never know, right? So this is how hash functions became very important. So when a new block, to be called current block, is about to be uploaded, a hash is calculated from the current block as well as by using the previous block, information in the previous block. तो क्या हो गया? Old plus current will become new block. So in the chain of old, this is how. So when this block was included, it considered these two. So this hash is included in this. Similarly, when this will be created, this hash will be included into this, right? So what is happening? If this hash is secured, this hash has to be there. And if this hash is also correct, then it will refer to the previous hash. So there will be a series of hash functions that would keep on being generated. Now, each hash is uniquely generated by considering previous hash. Therefore, if someone comes and tries to add new hash, it will never take, because it will not match with the previous hash, and it will require these two hashes to be matched completely, right? So the hash is recorded in the current block together with the collection of the transaction, and then an approval process is required before registering the uploading block, right? इसको हम लोग और भी अभी डिस्कस करेंगे. So as technology advances, new and emerging technologies are there, right? So even if someone falsifies some data in a block, this is what I said, the hash will not match, and one cannot do that. And therefore, if I have a chain of blocks, I can always trace it back and check whether if there was some block which is false. So number one, you cannot add a false block, you cannot modify this block, and this information is permanently saved, right? Although there is a mechanism by which we can keep it in a separate chain, what were the retracted blocks, so that is some other story. Okay, but for now we should understand that blockchain can realize falsification immune data registration mechanism. Okay, so a blockchain is recognized as a distributed digital ledger, although the term blockchain is spread in many literature. Okay, the term does not have a standard definition. So let us understand it that this is a finite list of blocks, right? It has two parts, header and transaction. Each header in the block has a pair of hash values, one calculated from the header of the previous block, right? For presenting the order between two blocks, and the other calculated from the transaction part of the current block. And these older and the current block are merged together. So the past transaction is used for recording one or many transactions. Okay. So in a blockchain, every block is identified using the hash value of the header. Every transaction can be identified by the hash value, right? Since this is managed in a decentralized manner in a peer-to-peer network, every data is open to the network and is recorded in the block. तो ये होता है, previous hash ले लिया, करंट हैश ले लिया, बिटकॉइन एटसेट्रा में एक नॉन्स भी होता है, नॉन्स को हमको जरूरत नहीं है एट दिस पॉइंट ऑफ टाइम, एंड जो भी ट्रांजेक्शन हो रहा है डिजिटल सर्टिफिकेट बन रहा है. नाउ दिस विल बी यूज्ड in while creating the new block, and here previous hash taken from this one is used, and then a new hash is created, merged together along with the new information. So ये old certificate हो गया, old digital certificate हो गया. So while creating the new digital certificate or renewal of a certificate, in reference of old certificates will always be placed. So what will happen, suppose we are issuing meteorological certificate to some OEM every 3 months or 6 months. Suppose during certain inspection, if he failed or if his product failed, and then he had to improvise again because it could not qualify, even that information would also be placed, right? So it is just like giving an exam, and even if you failed in some class, it will always be stored as a information. So you can always check whether the company has been receiving renewed certificates continuously or not, right? So so this is what, and therefore right now nonce is not required, so we can skip this. Actually nonce is one parameter which is generated exclusively in financial transaction based blockchains, where there will be proof of work verified and issued by someone else, third party agency on the internet, and there may be millions of people who will certify this. So for that purpose nonce is required. So since in our application we are not requiring nonce at all. Okay, so how would we design a blockchain for meteorological traceability? So let us see that. The address of the internet URL and the hash of the scanned image are recorded in the block. Digital calibration certificates are proposed recently, which may reduce the data size. Okay, whenever the calibration laboratories issue a calibration certificate, they upload these data on the internet in the form of blockchain, right? The data uploaded from all over the world is regularly collected to make a block. Okay, so certification is being done. So blockchain has drawn attention, which embodies Bitcoin. In recent years, many use cases have been shown. Okay. In fact, to the best of my knowledge, however, a recording system of calibration certificates equipped with a visualization function of the traceability chain has yet not been published so far. So, and that is the reason why we referred to this research paper. This is the original high value contribution. Okay. So, as a measure of record data, which possess nature of an unbroken chain, the blockchain is appropriate. Okay. So, hence, an application of the blockchain to the meteorological traceability, namely the system of recording calibration certificate, is being visualized here. So, it will have four parts, four subparts. First is requirement of the recording system, design of the blockchain, operation of the recording system, and then justification that the block is appropriate and it should be added, right? So how would we, what is the requirement of the recording system? What would be? So first, a registry system of the digital signature for calibration certificates for assuring meteorological traceability is needed. And what would be their constraints? First requirement will be any recorded data shall not be easily falsified. For a violation of integrity in data, it must be detectable. Second requirement क्या होनी चाहिए? Both authenticity and integrity of the digital calibration certificate can be verified, right? Then third requirement is for any certificate registered in the system, it can provide data for presenting meteorological traceability up to the primary standard. And then the fourth requirement is the system shall have appropriate means to control the access to data. Okay. The registered data shall remain unknown to everyone except intended user. So therefore, we are still maintaining the privacy and access control. So requirement 1 and 2 are intrinsic. Requirement 3 and 4 are functions which are anticipated but not attained in a conventional paper-based calibration certificate. So design of the blockchain क्या होगा? Every laboratory has its own unique identifier of the laboratory and assigns a unique identifier for every calibration in the laboratory. for identifying a calibration in the world, we need identifiers both for laboratory and calibration. So, what is happening? Record of the current certificate, ID of the certificate, ID of the laboratory, digital signature of the laboratory, then hash of the encrypted certificate, URL of the encrypted certificate. So these many are the information. So this is secured by public key digital signature scheme, which everyone can see, right? And then encrypted information of the parent certificate. So encrypted information is coming from the previous block. So symmetric encryption key, only the person having the key can see. So only he can trace it back. Okay. So this figure shows the design of a transaction which consists of two parts. One is record of the current certificate and encrypted information of the parent certificates, right? So current certificate में identifier of the laboratory हो गया, calibration identifier of the calibration in the laboratory हो गया, digital signature of calibration certificate हो गया, URL हो गया, right? So operation of the recording system क्या होगा? When we are creating a new certificate, old certificate will be considered. So for the customer, when a certificate is received, it is referred to the lab, previous lab, and this lab has also approved certification of the even its previous lab or product. Once again, that will also be included in this way. This is the reverse, and finally somewhere primary standard will also be referred to. And this is how a blockchain will be created with absolute traceability, right? So issue of the calibration certificate. When a laboratory issues a calibration certificate, the laboratory publishes a transaction which includes the data defined as we have just discussed just now, right? At the same time, the calibration laboratory provides the clients all the information included in the transaction and a hash value. Okay. अब verification of the calibration certificate क्या होगा? Both a public key, digital signature scheme and a symmetric encryption scheme are used. Once the certificates is identified, the authenticity integrity can be verified from the digital signature which is encrypted by the public digital signature. So ये publicly हो जाएगा. Only the person who has the password, who has been which has been used in the symmetric key encryption scheme, can only decrypt the certificate and information to the of the parent certificate. So this protocol implements your second requirement. We were talking about 4 requirements now. And then visualization of the meteorological traceability. Anyone who owns a calibration certificate and the password for the certificate can both collect all upstream certificates, the previous ones, obtain a tree of calibrations which represents meteorological traceability of his or her measuring instrument. So this is how he is always assured that what he gets is absolutely correct. So here is the basic protocol for implementing the aforesaid function. Anyone who has the identifier of the laboratory, identifier of the certificate, and the password for the calibration certificate can decrypt the transaction so that the following can be obtained: calibration certificate, the data for parent calibration certificate consisting pairs of an identifier of the transaction and a key used for encryption. By repeating the procedure for these pairs obtained from the procedure, by repeating this procedure, we can collect all upstream calibration certificates and obtain a tree of calibrations eventually. This implements your requirement 3. Then let's see the way to implement the requirement 1 and 4. So falsification immune record. So blockchain is inherently immune to falsification, right? So by giving the right of registering blocks only to particular organization, the requirement one has been achieved. So this is not a public inclusion of the block, rather only central agency will include the block. In our case, it may be the National Meteorological Department who will do this. So the Ministry of Consumer Affairs will be the apex body in case. And since we have a centralized body for issuing such certificates, we don't require nonce as is being used in the financial sector, right? Then control the viewing rights of the calibration certificate. So since all calibration certificates are recorded after encryption, it has a password. So owner of the calibration certificate and the laboratory which issued a certificate only can see this. Owners of downstream certificates, they can see the upstream certificate by using the basic protocol as discussed. So therefore, requirement 4 is also attained, and therefore all the four requirements essential for secured blockchain enabled system are met. So now we can just discuss what we have talked about. For open type blockchain such as Bitcoin, who registers block? It was important, then that is why nouns were there, right? As the blockchain is operated in a decentralized manner, there is no one who has right to register. If a fee is charged when block is uploaded, this mechanism of knowns may work, right? But in our case, since ministry is doing it or the government is doing it, right? Government is already working on the public money, so need not to be rewarded in this blockchain manner. So we don't require nonce and this kind of thing. So here we do not assume such charging for the blockchain handling the meteorological traceability. So if all laboratories which issue certificates were trustworthy, a blockchain in which all laboratories were allowed to register, the block could be used, right? And therefore, the proposed system works perfectly only when all the calibration laboratories in the traceability chain use the system. And therefore, somewhere we have to encourage and implement blockchain enabled certification system all across the country as a system. It is possible very conveniently because we have our sub agencies also, head office, sub offices, different other laboratories, and this is all computer based system. So we can have a networked system on the blockchain, just like the banks carry out the core banking, and all the laboratories would be interconnected and would be linked with respective in multiple blockchains. So even if some laboratories or users don't register the calibration certificate, this system still can work. For such cases, they will just upload a blank file, right, instead of a calibration certificate. So they will just be a passing body. Another point is commercial calibration laboratories seldom use their highest level measurement in standards, which have been calibrated by external and upstream calibration laboratories during routine calibration services. Instead, working standards which have been calibrated in accordance with laboratories' internal calibration procedures are often used. So certification का reference जो होगा, it must be very well referred. And therefore, if the records of the internal calibrations are not registered additionally, the chain of the calibration laboratories can be traced, but not for the meteorological traceability. So this will create a limit also. So in order to establish a complete meteorological traceability, internal calibration records must be registered as well. So every unit has to participate in creating blocks. So immediate benefits for the calibration laboratories to do so is little. However, in practice, gradually it will improve their reliability and reputation. Voluntary use of calibration laboratories will facilitate a practical functioning of such a system, right? So as already stated, that the proposed system works perfectly well when all calibration laboratories in the traceability chain use this system. Okay. The laboratories are free to use any blockchain system ranging from a simple storing system to a sophisticated one, as discussed. So, some laboratories might be reluctant to disclose the information in the downstream laboratories. So, once again, it will be a part of regulation. So, in such a case, they may provide the decryption password only to limited users. So, that is also okay. So, when a calibration certificate is retracted, it can be placed in a some other chain, right? So even if some block is retracted, we can create another blockchain in which only retracted certificates are uploaded, but still retracted blocks would always be existing. So one can always check, right? So a use case of the blockchain technology applied to meteorological traceability has been discussed today. And this system enables the owners of the calibration certificates to trace the traceability chain to the origin, right? Only a basic concept has been talked, and there may be several more aspects to be covered. So let's wish that this system will establish a transparent and reliable meteorological traceability system, right? So this was the research paper published with the title Blockchain Technology to Visualize the Meteorological Traceability, published by Toshiyuki Takasuji from National Meteorological Institute of Japan, right? So this was just one exposure to the community today that we need to bring this platform for certification, right? So thank you so much, and I believe uh, I have taxed you all heavily, but it was very necessary to expose that what are the new platforms to talk about, and we must work on these together.
Thank you very much, sir. It was a wonderful presentation today. And actually, you know what, where we were struggling, what is this whole concept? How to use this blockchain? How to make a single portal? You know, we are struggling on these issues. And I think you have basically used this particular presentation. Tomorrow, I will, sir, kindly share this presentation. I will
Yes,
share
yes,
to all the participants, and even
right.
tomorrow with the secretary. Sir, yesterday I was discussing with him that tomorrow we
Right.
have this presentation of Professor Rajput Saab, that what we are doing and this emerging technologies in legal metrology. He was
Right.
very happy. Santosh ji, in the meantime we were discussing, can you please
Yes, sir.
start taking the photographs or
Okay, sir.
Yeah,
making
that
of
is
Okay.
fine.
panelists,
Okay, sir.
so
Okay,
we
sir.
can take picture of all the participants? Sir, will you just take for 5 minutes more, sir? We will
Yes,
take the
yes, please,
photographs.
please. In fact, I have taken much
So,
more
अभी
time
इधर
of the community. So, in fact, I should be sorry for that, for
No, no,
taxing
it is very good.
additionally
Thank you.
for
Thank you.
24
But sir,
more
your
minutes.
presentation was very good. And actually, up to some extent, I could understand what we have to do. But sir, day before, sir, we have with us, there are two questions. I just want to reply them.
Yeah,
How, sir, how can I apply for the legal methodology for stamping of weights and weighing machines? You know, in most of the state, I don't know from which state you are asking, but in most of the states, the portal is online. You can apply on this online portal where the user is actually using this weighing machines or the weights, and can it get it verified from the local legal metrology officer directly. The next question is, respected sir, can be used the blockchain for renewal of weighing certificate annual base from department mail to retails mail without any middle person? See, as far as re-verification is concerned, there is no need of any of the middle person, because now it is very easy. Anybody can apply. Even we, for making it very simple, all the legal methodology processes are being now online. Even you, if you want to get a registration, you can directly apply on the central portal or the state portal. If you want to get the nomination of the director, you can directly apply. For model approval, you can directly apply. So all the processes are now online, and anybody can apply directly through this through these portals. and the new certificate, revised certificate will be issued. As sir has already told na, that we can change the certificate. Suppose something wrong and we want to replace the
आपको माइक म्यूट हो गया है सर.
Sorry. So, sir, what the applicant, I'm sorry, what the applicant, what we can do, even the data which is already available can be used next year. This is the purpose of the portal actually. This is not the blockchain. Blockchain is, we are just uploading the final product in the system to so that it can be seen everywhere. Sir, the last week I was discussing with the OML participants. We were having one meeting with the PTB Germany, and they were asking, they were saying that whether it is required to be having this online portal, not online portal, sorry, this blockchain, because these certificates are available on the government portal. And the purpose of this blockchain, there should not be any change by anybody, or nobody can make this certificate, tamper this certificate. Can we have some another technology by which it can be ensured that it is not tampered?
Yeah, actually, even XML based certification system is also there, which you
Yes,
were
sir.
talking about. So that can also
Yes,
be
sir.
implemented. But
Yes, sir.
actually, the blockchain application, what we discussed today, basically it is being done from the angle of the user. Suppose I am a mega manufacturer of some product and I require several certifications of several of my products or intermediate components, right? Somewhere, if I want to trace back all the certifications and intermediate bodies through which it has been finally linked with the international standards, right? Even, for example, we have BS3, BS6. Does it really comply well with the European standard or American standard? Or if I am exporting my product somewhere else and if I have obtained certain certification. So basically, blockchain based certification system is a trust generator system. Right now, in our case, we are issuing them a certificate and we are saying that we are the government and whatever we are issuing is full and final, right? No matter our backend might be well updated or might be obsolete, right? We issue a certificate and that is the order of the king.
Yes,
By
sir.
blockchain, what we are doing, we are empowering the user to be able to trace back even my own calibration procedures, certification, updates, and models of the instrument I have used. The way I had talked about the application of the battery recycling, right? Right from the metal which was used for creating my battery, I can go to the final recycling component. Okay. So blockchain is for the sake of immutable certification system which is very well traceable back.
Yes, sir. Thank you. I would like to request all the participants to kindly switch on their video so that we can take the photographs and can put it on our Twitter handle. The Twitter handle is at LMGOI. My request is kindly make like and retweet the portal. Santoshi, have you finished?
Wait for a minute, sir.
In fact, today is a very pious day for Hindus as well. We are celebrating Shivratri. So, and fortunately, we are from Varanasi. So, right now, I'm talking from Varanasi. So, wish you all a very happy uh, festive season and a very good Shivratri, and to all other people who are here in a joyful celebration.
Thank you. Thank you, sir. Thank you. Happy Shivratri to all.
Yeah.
Sir.
Thank you. Thank you very much, sir. Thank you, Professor Rajput Sahab, who has
Okay,
made this
thank you very
topic very
much,
simple. Sir, my request is kindly share this presentation, and
Yes, yes, I will do.
and if you will permit, we will upload this video also on the portal, so
Right,
that
right. Please do.
the participants can see at any point of time. It will be useful
Yes.
for them.
Certainly, certainly.
Thank you. Thank you, all the participants. Next time, next week, sir, we are planning to have a presentation from the National Physical Laboratory Scientist
Very
on calibration of even class weights. How to do the calibration of even class weights is a very interesting and important topic. Even in India, many people are not aware of that, how to do that. It's a very good technology, very good practice actually, procedure. Next week, we are having on this. With this, I would like to thank all. Thank you very much, sir. Thank you.
Thank you very much. Okay, thank you. Have a good day.